In the first session, we just looked at a few data types. Let me go at it from the top to the bottom. We looked at how to print something in Python, simple computations, out of which I told you that the modulo operator is something which you can, remember because it is not that intuitive. It gives you the remainder, and this is the floor division, which gives you the quotient. Then we talked about a few rules when we are trying to create a variable. I told you Python is a case sensitive language. If you have a capital X and a small x s, they are both different variables in Python. And I told you that you cannot, start your variable name with numbers or special characters. Only special character allowed is an underscore. We've created a few variables. I gave you a simple Darcy's law example to tell you where this can come of help, and I gave you the entire, idea about you being the coder of a software, of a tool. You should think of your program as if you were developing something for your company, right? And the key behind every good programming practice is how much can you automate it. So that's why variable assignment is a good step towards it. And we saw that as we keep on varying various values, the resultant formula, it keeps on auto updating. If in case you wanted to print a variable, we looked at input statements and how it accepts in default format of a string. We had to typecast it to a number. We looked at the f strings, formatted string to display a string along with the variable's value, not just the variable's appearance. Then we repeated the Darcy example with all these advancements. Then we looked at a few data types. We looked at strings, how to slice a string, discussed a few doubts. We looked at list, how it is important. It's like a bag of various kind of details. Then we looked at one of the important data types. We talked about mutability aspect of strings and like immutability of strings and mutability of list. Mutability can be thought of as the ability to be modified. Then we talked about a tuple. Some people call it a tuple, whatever you might want to call it. That's all good. We just saw that a tuple is nothing but a list with parentheses and it can never be edited again. Further, we looked at one of the important data types, which is dictionary. And a dictionary was a good practice because we could store things with a mapping, with a title and their respective details. I told you that we can keep on updating a dictionary, add more details as we go on, access the original details, edit them. The dictionary keeps on varying. Finally, I also gave you a sneak peek into something which we'll be looking at tomorrow. The fact that it can be converted to pandas data frame and played around with, plotted around with, and so on. It looks really pretty when we print it in the data frame format. Yep, there we ended the session. We had a few discussions. All right, all set and ready for session 2. Okay, in this session, we will be looking at, finally, you can see that on the title as well. We'll be looking at loops, functions, and if-else statements, right? As always, I mean, I'll stop after I complete my content and we will be flexibly going to, revise a few things, discuss whatever doubts we have and all. So don't worry if when I say something you don't get it, don't worry. I will, of course, give you enough time to go back on it and discuss it with me. So type your queries in the chat and I'll come back to them later on. Right? Okay, so the topic in here is there are 3 topics we have to look at. Okay, there are 3 topics we have to look at. Let me type the title here. If-Elif-Else statements, functions, and loops. And my favorite are the later 2 sections because they give you more power, they give you more abstraction, they allow you to become a mature programmer, because all the algorithms that you see in textbooks and whatever you are reading in computational physics, for example, you can code them up as your customized algorithm inside a function, and you can call that function your own creation and then keep on using it wherever you want to go. So let's start with if-elif-else statements. Okay, I have an example and we will start with that example. Okay, so the topic one is if-elif-else statements. Before we even start with it, let me first talk about comparisons in Python. Okay, let's first talk about comparisons in Python. In Python, comparisons can be done using these things. Okay, greater than symbol, greater than equals to symbol, less than symbol, less than equals to symbol, double equals to, not equals to. All these are, this is the exhaustive list of comparisons possible in Python. And you can use greater than equals to, and the result of them will be, the result will be a truth value. Okay. In Python, true and false are two keywords. You can see as soon as I type a word true, it comes out in green color, which is Python's way of telling you that, hey, Mike, this is a keyword that I already have reserved in my memory. So don't you dare use it like a variable name. All right. Similarly, a false, if you type it again, it comes out as green color. OK, so the result of whatever comparisons you set up, if the comparison is true, the result will be true. If the comparison is false, the result will be false. OK, and always remember true in Python is equivalent to 1 and 0 in Python is equivalent, false in Python is equivalent to 0. OK, all right, let's see some examples. For example, is 5 greater than 3? The answer to this comparison should be true. There you go. Is 3 less than 5? The answer is true. Is 3 greater than 5? The answer is false. Is 3 double equals to 3.0? Again, there's a difference between a single equals to symbol and dual equals to symbols. A single equals to is an assignment. A dual equals to is a equality check. Okay. Okay, let me ask you this. Let me see the answers in the chat. What would you expect this to print? What would you expect this to print? And think about it. What should be the result of this? I'm looking at the chat if in case anyone wants to answer. 3 is being checked for equality against 3.0. Kapil says it should be true. Okay. Perfect. Yep. I think it should not be equal. I mean, even if I ignore all the Python knowledge I've had, I just focus on, I see mixed answers in the chat. Both are right on their own senses, but I will tell you what Python thinks of it. And just the first session that we learned about, that knowledge is sufficient to answer this. Did we talk about data types in the first session? If I check the type of 3, it's an integer. But if I check the type of 3.0, what will be the type of 3.0? Anyone? Type of 3.0, what should be the output of this? Float. So do you see some reason why Python might be some hint behind why this is giving you? This should not give you true. Wow, this should not give you true because the type of these two data types are not equal. So there we go. We saw a loophole in equality symbol. OK, the data types of both of them are different. But when you are checking for equality, they are saying true. But there is a limit in Python up to which this can be true. And after that, it becomes false. So you can see this is still true, which is a very, very significant loophole in Python. So be very, very cautious when you are trying to solve some algorithmic problems where the significant digits are they matter a lot. I mean, even this much difference is considered to be a significant difference. Then make sure you remember that Python will interpret as true. It's not false. We are seeing in our naked eyes that this is not equals to, they are not equal, but Python has a limit up to which it assumes it assumes equality. So this is a red flag right away of equality check. It's only an approximate equality check, and it's not a clear equality check. Okay. I've had problems with this in the past. So please remember, it is an approximate equality check. Because for oil and gas engineers, I mean, we deal in decimals a lot. So this can cause some problem like it had caused me. So always remember this, right? But normally, otherwise, it will always give you what you are thinking. OK. Similarly, if you check for 3 greater than equals to 3, what should be the answer to this? The answer to this should be true. 3 greater than 3 should be false. OK. Is this very clear about the comparison statements? Let's check something else. 3 not equals to 3. 3 not equals to 3. The answer to this should be what? The answer to this should be, is 3 not equals to 3? Is that true or false? 3 is not equals to 3. It's false, right? I'm giving you a practice of this because this will be a key component when we talk about if-elif-else statements. Okay. So pay very kind attention to this. What if you wanted to combine multiple conditions together? The Boolean logic comes in, the AND gates, the OR gates, and all these kind of things, they come in. Combining multiple comparisons together. Okay. Combining multiple comparisons together. For example, now I want your answer to this. 5 is greater than 3. The way to combine them is AND. For example, I want to combine two conditions, and 3 is greater than equals to 4. Okay. Any guesses what should be the output of this? You can see that I'm trying to bring that good old BODMAS kind of mindset here. I'm putting everything inside parentheses, whichever I consider to be one expression. I'm putting that inside a parenthesis so that that execution happens first, and then the AND operator is executed. Okay, always remember that. Whenever you are in doubt, use parentheses, just like in plain math we do. We always explicitly apply parentheses. I never understand operator precedence, so never try to get confused. Always use parentheses. So let's I see some answers in the chat. Let's look at what should be the answer. So 5 is greater than 3. The output of this is, let me type comments here. 5 is greater than 3. The output is true. 3 is greater than equals to 4. The output is false. And like we all know about the AND gate, true and false will be false. Brilliant answers. So you can see the false comes in. Let's see whether we can also, like in C++, we can use ampersand symbol in place of AND. Can we use it here as well? Yes, we can. Okay. So we have AND operator. We can also, now if I replace this AND with an OR, can you tell me what will be the answer? I'm replacing AND with an OR. Does that change anything or does that keep it the same? Yes, exactly, Soumya. So it becomes true. Okay. It becomes true because AND requires both the conditions to be true, whereas OR just wants one condition to be true. Let me give you an example, a bit of a complicated example, and let's solve that together. Complex example. Okay. A bit of complexity. Let's make it like this. Okay. 5 is greater than equals to 3 and 2 is greater than equals to 4, or 4 is not equals to 4 and 5 is equals to 5. I want you guys to tell me what should be the answer of this. Okay, try to use not use Python first up, and then we will talk about it. I see quick responses. I see trues already. Good stuff. Let's I cannot know the answer already because I just randomly created this question, but let's see if you are thinking the same way I am thinking. Okay, let's go at it one by one. Okay, let's solve this case first. What should be the answer output of this case? 5 is greater than equals to 3, which is true, and 2 is less than equals to 4. 2 is less than equals to 4, which is also true. So this becomes true. True and true is true. Or now whatever we don't care what is here. So yep, I appreciate the quick answers. So this should be true. So I hope everyone's very clear with combined and individual comparative statements. Okay, these are called logical comparisons in Python, and all these are called logical operators. Okay, so we can name it to be logical comparisons in Python. Okay, now let me use one example. Example is, this is the question, this is the problem statement. Ask the user for a porosity input, and based on porosity values, display the outputs accordingly. Okay, so basically I want to type a input statement, and based on that, so input statement, for example, porosity is an input. Right now I'll provide none. Okay, just a placeholder. Then what I will do is I will apply this if else condition. And this is where we will understand if else conditions. You see, every if else condition, it has the center of it is the logical comparisons that we just saw. Okay, so the logic here is, if whatever porosity value is entered here, if that is greater than 20%, we print that hey, porosity is greater than 20%. Otherwise, we print porosity is less than 20%, whatever. Okay. So are we able to understand what I mean by here? Okay. Okay, let me do something. Okay, let me ask the user input. Hey, enter porosity in percentage. Now, again, looking at the chat, I'm asking you, is this code block? Is this code block correct? Or is there some problem based on the last session? Is there some problem with this? The hint is I'm using input statement. Do you see some problem with this? I'm asking for a user input. Exactly. So Kapil has spotted it out. We need to remember percentage is fine, but the input statement, the result of the input statement, which is stored in porosity. Yes, Abhishek, it is going to be a string. And can we compare a string with a with this with what do you call, with a number? No. Will the code run? Let's see. 25. The code will not even run because this comparison statement, it assumes that the data types on both of the sides of the comparison are eligible for comparison. You cannot compare an apple with an orange. You need to compare a good apple with a bad apple. Okay, so that's the logic. But if I replace it with let's say float. Okay, now if I run it 25. Now tell me, if I input 25, what will be the output of this entire code block? Expecting some answers from you. If I press enter, what do you think will be the output? Will it be the first section or the second section? Will it result in? Yes, if condition is true. So if I provide 25, what happens? Now let me explain, let me postmortem it and explain it what is happening here. So the step one is the porosity input is taken in. Then we get to this line. Okay, this line, porosity is greater. So first this is executed. Okay, porosity greater than equals to 20. So what is the value of porosity? 25. It checks whether 25 is greater than equals to 20. The answer, if I provide this 25 is greater than equals to 20, this gives me true. So basically, if condition checks whether this, whatever follows the if condition, that statement, whether that statement is true. If that statement is true, the block within the if statement, always remember, as soon as you type the if statement, for example, if I see here, if true, and I provide a colon and I press enter, by default, you will see that the line starts here. It's something similar in C++. If you have seen in C++, the if condition has this curly braces thing. Okay, you have these curly braces and all. Whatever you want to write for this if statement is within these curly braces. But in Python, you have this, which is called a tab, which is called an indent. Okay, print true. Okay, so you can see this is what happens. So basically, if this was false, the true is not printed. So this should be very clear about if condition, what happens after if condition. So if condition checks whether the next part of the statement, is it true? If yes, get inside, print whatever, or do whatever is inside, otherwise get out of here. That's all. So basically 25 is greater than 20, which is true. This part is printed. If I repeat the same thing with 17% porosity, you can see porosity is less than. Basically, it means the other else statement is printed. Now you will ask me that, hey, is this all? Okay, is this can we only have two statements, if or else? What if I wanted to add something like a switch kind of thing, that hey, if this is true, then this, otherwise if this is true, then this, otherwise if this is true, then this, if not, if none of them are true, then finally this. Remember, else is always the worst case scenario when nothing is true. Okay, let's look at one more example, which has elif as well. Okay, which has elif statements as well. Let me find that example. Okay, I have already I'll copy it here directly to save some time. So basically what's happening here is I'm asking the same porosity input again. Now there are two conditions to be checked for, and then there is one else statement. Okay, first I will check whether this condition is true. If that is the case, then this will be printed. Then if this condition is not true, then elif is checked for. If elif condition is true, then this is printed. If none of the above two conditions are true, then the final one is printed. So the logic is, if porosity is greater than 25%, then this is a porous sandstone. Otherwise, if porosity is less than 25 and it is greater than 15, then it's still a sandstone, but it is a tight sandstone. But if both of the conditions are false, then I would say that maybe it's a carbonate. Okay. So let's check for various conditions, and I will ask you again so that I verify whether you have understood the if else. So suppose I provide 27. Okay. I need your answers in 3 words. The options are condition 1, condition 2, and last case scenario. So if I provide 27, which condition will be executed? Correct. If I rerun it, if I provide 25, which will be executed? Again, first, because the equality sign is in first. If I repeat this again and I provide, let's say 17, which condition will be executed? Condition 2. You can see this is a tight sandstone. And if I repeat this and I provide, let's say, if I provide, let's say minus 100, what will be executed? I'm providing minus 100. So pay attention, what will be executed? It's very simple. Just focus on one condition at a time. If that is true, yes. So basically it checks, as I provide minus 100, then porosity becomes minus 100. Is minus 100 greater than 25? Of course not. Goes to the next condition. Is it less than 25? Yes. Is it greater than 15? No. So it becomes false. So this is not printed. Hence, else condition is printed. So basically, maybe it is a carbonate. So basically, we have to now. What would you suggest? There is some problem with this logic, right? So the good thing should be to provide one more elif statement. Elif poro greater than equals to, let's say we provide a threshold of valid porosity values to be 3%. and poro is less than 15%, then we provide this control C, control V. Otherwise, the worst case scenario should always be those ones which may be also good enough in capturing some errors. Invalid porosity value. Okay. So if I run it again and I provide the -100, you can see invalid porosity value. So are we very clear with the if else conditions? Okay, I'll paste this entire, if you want to, run the same thing in your code notebook, I'm pasting this in the chat. But are we good enough with the if else conditions? Okay, very easy, very understandable.